Welcome to our series on RAG, Retrieval Augmented Generation. We're experimenting with new ways to teach AI. First one is using popular storylines to make complex concepts stick. We really want to know, is this working for you? Whether it's too simple, too dense, or just right, your feedback helps us improve. Leave a comment with your thoughts, what works and what doesn't, or perhaps suggestions for future topics. If you find this helpful, don't forget to like and subscribe.
Welcome to the Survival Manual. In the desolate landscape of modern AI deployments, Retrieval Augmented Generation, or RAG systems, are our lifelines. They promise grounded, factual answers by connecting powerful language models to a trusted knowledge base. But running a RAG system in the wild is not a simple deployment. It is a constant, high-stakes survival mission. The true challenge is not building the system, but sustaining it, ensuring it remains accurate, efficient, and trustworthy long after deployment. We are operating in conditions where failure means mission compromise, hallucinated facts, and catastrophic loss of confidence. This manual, built on years of hard-won experience, provides the essential protocols for measurement and evaluation. We will lay out the precise metrics and tools required to continuously monitor and fortify your RAG systems, turning a fragile experiment into a resilient, functional outpost. If you are serious about reliable, production-ready AI, these protocols are non-negotiable. Let us begin. Our first and most vital warning is this: the vibe check is a death trap. When you initially test a RAG system, the illusion of safety can be profound. You ask the bot a few questions, and it answers fluently, cites convincing sources, and generally looks impressive. We assume it works because it sounds smart. This reliance on gut feeling, the simple vibe check, is the illusion of safety. It makes us lazy and opens the door to silent, catastrophic failure. The reality is far more brutal. What if those beautifully written answers are expertly constructed lies? What if the bot cites documents or intelligence that simply doesn't exist in your knowledge base? The danger is that the system operates just well enough to maintain the illusion while slowly degrading its factual integrity. In any survival scenario, you cannot improve what you cannot measure. You cannot fix what you cannot detect. Relying on vibes is a recipe for the most dangerous kind of failure, the kind that happens quietly until everything collapses. To measure and sustain a RAG system, we must first understand its architecture as two sequential, critical missions, each with zero room for error. Mission 1 is retrieval, handled by the scout, which acts as the system's librarian. The scout's job is simple: find the correct intel from the vast knowledge base. If the scout fails and brings back the wrong documents, the first point of failure is triggered. This is the issue of the wrong intel. The LLM, regardless of its intelligence, cannot succeed if it is fed irrelevant or incorrect source material. This wrong intel leads to a critical handoff to Mission 2, generation, handled by the comms officer. The comms officer, which is the large language model, must use the retrieved context to formulate an accurate and truthful message. The second point of failure occurs here, even if the intel was correct, if the model fails to adhere to it or simply fabricates a response. This failure mode is a false message or a hallucination. Our evaluation protocols must rigorously test and measure the success of both the scout and the comms officer across this critical handoff, ensuring both retrieval integrity and generation accuracy. The first step in fortifying our operations is Protocol 1, checking the scout's reports. Before we trust the final message that the LLM generates, we must audit the raw intelligence that was delivered to it. Did the scout's top K documents, meaning the top handful of retrieved results, actually contain the answer we needed? We need objective, hard data on the quality of our retrieval step. To measure this, we turn to the proven metrics of classical information retrieval. Our retrieval integrity dashboard is built around two core metrics. Recall at K and precision at K. Recall at K tells us if the critical information was captured at all. Low recall is a critical failure because if the answer isn't retrieved, the system has zero chance of success. Precision at K tells us how much noise or garbage was mixed in with the signal. Low precision wastes energy and invites error, making the LLM's job much harder. We must keep both indicators well into the green zone to ensure our comms officer has actionable intelligence. Let us explore these critical retrieval metrics using the analogy of a fishing net. Recall at K addresses the question, did we catch the right fish? This is the most critical survival metric because it determines the potential for success. If the factual answer resides in document A and our top K results, say the top 5 documents, do not include document A, then recall is 0. The comms officer, the large language model, has absolutely zero chance of successfully answering the question. High recall is not just important, it is non-negotiable for system survival. Conversely, precision at K asks, how much trash did we catch? Precision measures the relevance of the documents retrieved. If we retrieve 5 documents and only one of them is actually relevant to the user's query, our precision is extremely low, at 0.2. This low precision forces the large language model to sift through copious amounts of irrelevant garbage, significantly increasing the cognitive burden on the model. This high noise level exacerbates the problem known as lost in the middle, where the model overlooks critical information buried in a long, irrelevant context. Low precision raises operational costs and, more dangerously, delays critical answers, which can be fatal in the wild. While recall tells us if the intel is in the bag, the ranking of that intel within the retrieval list matters immensely. The comms officer, the large language model, pays most attention to the documents presented at the very top of the context window. Burying the correct answer is nearly as bad as not finding it at all. Therefore, we introduce metrics that account for rank. We have 2 key ranking metrics. First, MRR, the mean reciprocal rank. This is calculated simply as 1 divided by the rank of the first relevant item. MRR measures how deep we have to dig to find the first piece of good intel. A perfect score of 1 means the critical answer was the very first thing retrieved. A score of 0.1 means we had to dig all the way down to position 10. We must continuously strive to keep this score as close to 1 as possible to maximize LLM efficiency. Second, we have NDCG, normalized discounted cumulative gain, which is often considered the gold standard for ranking. NDCG assumes that multiple reports might be useful, not just the first one. It heavily rewards putting the most relevant pieces of intel at the absolute top of the list, ensuring that we maximize the signal-to-noise ratio in the critical first positions of the retrieval context. Let us see why ranking is so critical through a field report comparing Scout A and Scout B, both responding to the query. Enemy position? Scout A delivered 3 reports. Number 1, the critical grid coordinates, followed by a weather report and an old supply form. Scout A achieves high MRR and NDCG because the critical intel was delivered first. The mission proceeds immediately. This represents an effective retrieval. Now consider Scout B. Scout B also retrieved the exact same 3 documents, meaning its recall is the same as Scout A's. However, Scout B has low MRR and NDCG. The critical grid coordinates are buried at position 3 behind a weather report and an old supply requisition form. While the signal is technically present, it is buried deep within the noise. In a high-stakes scenario, that wasted time spent sifting through irrelevant context is a significant vulnerability we simply cannot afford. High-ranking metrics ensure we are not just finding the intel, but delivering it in the most immediate and actionable format possible. Once we have audited the Scout's reports and verified retrieval integrity, we transition to Protocol 2, verifying the message to base. This is where we grade the final broadcast generated by the comms officer, the LLM. Our objective here is to defend against the 2 remaining threats: hallucinations, which are factual lies, and irrelevant chatter, which wastes time and energy. Our complete framework for operational integrity in the generation phase is the RAG triad. The RAG triad defines the relationship between the user query, the retrieved context, and the generated answer, based on 3 foundational checks. The 3 legs of this triad are context relevance, answer relevance, and faithfulness. A failure in any single leg of this structure collapses the entire operation, resulting in an untrustworthy output. We must therefore measure all 3 of these metrics continuously, ensuring that the generated answer is not only factually grounded in the provided context, but also directly addresses the user's specific information needs. The RAG triad is built upon 3 essential pillars of truth. Pillar 1 is faithfulness, which ensures context adherence. The question here is straightforward. Is the answer derived strictly from the retrieved context? The failure mode for low faithfulness is hallucination, the most dangerous failure. For example, if the context says, ammo is low, but the answer claims, ammo is plentiful, that is a catastrophic hallucination. It is a lie disguised as fact. Pillar 2 is answer relevance. The question here is, does the answer actually address the user's prompt? The failure mode here is inefficiency. For instance, the user asks, what is the gate code? And the bot, using its retrieved documents, provides a perfectly faithful, correct summary of all base security protocols, but it never actually gives the 4-digit code. The message is grounded, but it is useless. This is an inefficient warning failure. Pillar 3 is answer correctness, which relies on ground truth. The ultimate question is the answer actually true? This requires a verified golden dataset, a set of mission-critical questions, and their known correct answers. We must compare the generated answer to this verified ground truth to ensure absolute factual accuracy, moving beyond mere adherence to the retrieved documents. Manually checking every single generated message for faithfulness and relevance is impossible under the rapid operational tempo of the wild. We must automate truth itself. To do this, we deploy a powerful, trusted AI we call the base commander. This is the LLM as a judge protocol. We use a highly capable, reliable model, often one like GPT-4, which is significantly more powerful than the model serving the user, to rigorously grade the output of our RAG system against the 3 metrics of the RAG triad. The process works as a continuous verification pipeline. The field unit sends the generated answer to the verifier, or base command. This judge model examines the answer, the retrieved context, and the original query, scoring it on faithfulness, relevance, and ground truth correctness. If the scores clear our high thresholds, we get a GO signal. We are essentially using our most powerful tool to check the work of the smaller, production-facing systems. This creates a continuous, automated verification loop for the integrity of our entire knowledge base, ensuring we catch degradation immediately. As we implement these new protocols, we must decommission the obsolete tools of a bygone era. We must discuss why metrics like BLEU and Rouge fail in the high-stakes environment of RAG evaluation. The fundamental problem is that they rely on n-gram overlap, which is simple word matching. They only count matching words between the generated message and the reference intel. They utterly lack semantic understanding, making them brittle, unreliable, and dangerous for factual systems. Consider a critical failure case. Reference intel states, the perimeter is secure. The system message responds, the boundary is safe. A human or a modern embedding model instantly knows these 2 sentences mean the exact same thing. But BLEU or Rouge sees 0% word overlap, resulting in a score of 0, classifying the message as a complete failure. This is a critical false negative. We discard these obsolete metrics because they cannot distinguish between subtle synonym usage and actual factual error, leading us to distrust perfectly good output. For RAG evaluation, we must avoid word-matching metrics entirely. If a full, trusted judge LLM is not immediately available due to latency, cost, or resource constraints, we cannot afford to fall back on the obsolete errors of BLEU or Rouge. A more robust, field-expedient alternative is required: BERT score. BERT score represents a significant advancement over simple word matching because it focuses on embedding similarity. Instead of comparing individual words, BERT score compares the meaning by leveraging contextual embeddings. It calculates the cosine similarity between the vector representation of the reference answer and the generated answer. By analyzing these vectors, it effectively understands that secure and safe are synonyms and represent the same core meaning. If the reference is the perimeter is secure, and the generation is the boundary is safe, BERT score compares their semantic vectors and returns a high score, like 0.95. This is a vast improvement over the word matching approach because it recognizes paraphrasing and meaning conservation. While BERT score is an excellent field-expedient upgrade for semantic evaluation, we must be clear that LLM as a judge remains the gold standard for comprehensive evaluation across the RAG triad. Before any of these metrics can be deployed, we must address the ultimate evaluation dilemma. The hardest part of this entire operational structure is not writing the code for the RAG system, it is creating the essential test data. You cannot verify answer correctness, that critical pillar 3 of the RAG triad, if you do not know the correct answer beforehand. We need a golden dataset. Our protocol for forging this essential dataset involves two crucial actions. First, synthetic generation, which we call the bootstrap. We use an LLM, often the same powerful judge model, to read through all of our core Intel documents and automatically generate thousands of question and answer pairs based on that knowledge. This creates a massive, large-scale test bed overnight, giving us the quantity needed for statistical power. Second, we perform human verification, or the expert review. We then bring in a human subject matter expert to review and validate a statistically representative sample of these generated pairs. This manual validation ensures that the LLM's initial synthetic work is accurate and confirms that our ground truth is, in fact, actually true and reliable. This resulting dataset is your mission simulator. It is the single most valuable resource for testing, and you must run your entire evaluation pipeline against it every single time you modify the RAG system or update the knowledge base. This brings us to the final protocol: trust, but verify. Survival relies on maintaining continuous operational integrity across the entire RAG pipeline, from retrieval to generation. Our final plan consolidates the metrics and tools we have introduced into 3 decisive actions. First, we audit the scout, focusing on retrieval. We measure recall at K to ensure we found the critical intel, and we measure MRR and NDCG to ensure it is ranked high, right at the top of the report. Second, we verify the comms officer, focusing on generation integrity. We measure faithfulness to ensure the message is true to the context, and we measure answer relevance to confirm that the generated message actually answers the user's question. Finally, we deploy the verifier, automating the entire process. The key tool here is the LLM as a judge, which automates the grading process across all metrics of the RAG triad. By embedding this continuous verification pipeline into your operation, you move beyond subjective confidence and achieve true, measurable, and sustainable trustworthiness for your knowledge base. We conclude with the core principle of this entire manual: measurement is the foundation of survival. A system you cannot measure is a system you cannot trust. These evaluation protocols are not optional extras. They are your first line of defense against decay, hallucination, and operational vulnerability. They are the essential difference between running a functional, resilient outpost and inheriting a silent ruin. By diligently applying the RAG triad, using robust ranking metrics, and employing the LLM as a judge for automation, you have the tools to guarantee factual integrity and sustained performance. Having mastered the essential art of measurement, we now look ahead to the next stage of survival. We are ready to build the fortress itself, the ML Ops architecture necessary for serving, caching, and continuously monitoring these systems against the constant and evolving threats of the wild. Proceed with rigor and vigilance.